In this lesson, we're going to take a look at position time graphs. Now, a position time graph does exactly what it sounds like. It tells us an object's position at every point in time. So these show object's position at each point or every point in time. Now, what that's going to allow us to do is not only see what the position is, but also how the position is changing. So over here I'm going to draw this position time graph, and the graph has two axes on it. The vertical axis of a position time graph is the position, so it shows us where the object is located relative to a reference point, right? So we start down here at 0, and then we can go 1, 2, 3, 4, and these are referring to meters. I did give myself a unit, so we're 1 meter from the reference point, 2 meters, 3 meters, 4 meters from the reference point. And these are positive distances, which means we're moving in front of the reference point. It is possible to go negative and have a negative position. That would be behind the reference point, but we generally set up our reference point so that the motion that happens that we're interested in is in front of that reference point. And then, of course, down here we have our time axis. Time will measure in seconds, and so same thing, we have 1, 2, 3, 4, 5, 6 seconds. So we have our position time graph, and then we're going to populate that with data. So we've got different graphs that show different things, but let's just go ahead and sketch a graph that maybe starts right here and comes up over to here, and then stays there for a couple seconds, and then comes back down. So I've got 3 distinct sections of this graph, and what we want to do is figure out which each one of those sections means. So we're going to just take this one time interval at a time. And when I say time interval, I mean from a start time to an end time. So we're going to start with our initial time of 0 seconds, and it looks like that motion changes right here at 2 seconds. So from 0 to 2 seconds, we want to know what happened. Well, we look at our graph and we can see the object started down here at the origin. So we have an initial position of 0 meters, and after 1 second, we can see it's moved 1 meter because now its position is 1 meter away from the reference point. And after 2 seconds, it's up at 2 meters. So our final position in our time interval, or our position at 2 seconds, is 2 meters. And so remember, the change in position, or displacement, is final minus initial. That's 2 minus 0. That is positive 2 meters, which means it moved 2 meters away. And so the shape of this graph, the fact that the position is changing through time, tells us that it's in motion, and because that position is becoming more positive, we can tell that that position is getting more positive. We can see that it's moving away. And so the slope actually tells us stuff. So a positive slope, and positive slope means that the position is becoming more positive as time goes by. Positive slope indicates that the object is moving away. So this indicates the object moves away from the reference point. Okay. Now let's go to that next little section of our graph. This middle section right here from 2 to 4 seconds. So our new time interval, 2 to 4 seconds. What's going on there? Well, our initial position is 2 meters, and every point in time along that line is also at 2 meters. So our initial position is 2, our final position is 2, and those never change, which means the position is not changing, which means this thing is remaining at rest. So I have a displacement of 0, and a displacement of 0 means no motion. And this is a horizontal line. Remember, horizon, the line between the earth and the sky, is horizontal. That's side to side. So a horizontal line, or horizontal slope, or no slope, horizontal slope means no motion. Okay? So again, looking at a section of a graph, we can analyze what it means just by looking. Positive slope, it was moving away. Horizontal slope, or 0 slope, means it's not moving at all because the position is not changing in time. And then we have this last section right here from 4 to 6 seconds, right? Started at 4 seconds, ended at 6 seconds. We started with an initial position of 2 meters. We end with a final position down here of 0 meters, right? It ended up back at the origin, 0 meters. And that means our displacement, remember displacement is final minus initial, that's 0 minus 2, that's negative 2 meters. And it's okay to have a negative displacement. Negative indicates direction, so this just means it moved backwards, back towards where it started. So that's our negative slope, and the negative slope indicates motion towards the reference. Okay. So 3 sections of our graph, 3 different lines, 3 different slopes, and they all represent motion, and by analyzing the sign of the slope, positive slope moves away, 0 slope doesn't move, negative slope moves back towards, we can talk about the object's position, how it changes, and how the object is moving.